Good morning, everyone. We are moving to the next topic of the first module of fluid mechanics and hydraulics. It is a differential manometer. So we have already studied what manometers are, U-tube manometer, and how it is used to find out the pressure at a point. Now the next type of manometer is differential manometer. So how is it different from a normal manometer? Differential manometers are devices used for measuring the difference of pressure between 2 points in a pipe or two different pipes. So as the name indicates, differential manometers find out the difference in pressure between 2 points of the same pipeline or 2 points in two different pipes. It consists of a U-tube containing a heavy liquid whose ends are connected to the points whose difference of pressure is to be measured. So it is also like a normal U-tube manometer, but for a normal U-tube manometer only one side is connected to the pipeline, but here both the limbs are connected to the 2 points whose pressure difference is to be measured. Now there are two types of differential manometers: U-tube differential manometer and inverted differential manometer. See, the first one is the U-tube differential manometer, and there are two different cases here. First case is the two pipes are at two different levels, and the second case is both the pipes are at the same level. Here also the calculations are done similar to a normal manometer, just that here it is connected to two different points. So here you can see point A and point B in two different pipelines, and also contains liquids at different specific gravity. So the pipeline A and pipeline B contains um, liquids of two different specific gravity. These points are connected to U-tube differential manometer. Let the pressure at A and pressure at B are PA and PB respectively. Now let small h be the difference of mercury level in the U-tube. See the figure. Small h is the difference in mercury level in the left limb and right limb. So the difference is h. Then y is the distance of the center of B from the mercury level in the right limb. See what is y? So y is this difference, mercury level in the right limb and the center of the pipeline. The difference is taken as y. Now what is x? The distance of the center of A from the mercury level in the right limb. So x is the distance from the center of A from the mercury level in the right limb. So that is x. Now as we have already told, these two pipelines are carrying two different liquids. So let rho 1 be the density of the liquid at A, rho 2 be the density of the liquid at B, and rho G is the density of the heavy liquid or mercury. Now we have to find out an expression for PA minus PB. Why we are finding out PA minus PB? Because differential manometer is used to find out the difference in pressures between 2 points. So here the 2 points considered are point A and point B, and the difference in pressure will be PA and PB, PA minus PB. So we have to you have to draw the figure. So I am not giving you the derivation, you have to write it on your own, because you have already done the problems based on this, so it is easy for you to find out an expression for PA minus PB. So based on the figure and also based on these assumptions, find out an expression for PA minus PB and write it in your notebook. Next type of differential manometer is inverted U-tube differential manometer. So it consists of an inverted tube containing a light liquid. So see the differences. Here the tube is inverted and the tube is containing a light liquid. The two ends of the tube are connected to the points whose difference in pressure is to be measured. So the second point is exactly similar to your manometer. Exactly similar to your exactly similar to the normal differential manometer. That is, the manometer has to be connected to the points whose difference in pressure is to be measured. and it is used for measuring difference of low pressure. So when the pressure is low, then we can use an inverted U-tube differential manometer for finding out the difference in pressure. So this is how the manometer will be connected. So it is inverted in position as compared to the previous manometer. So similar to the other derivation, here also you have two pipelines, and the center points are marked as A1 and A and B. S1 is the specific gravity of the liquid in first pipeline, and S2 is the specific gravity of the liquid in the second pipeline. And see where the datum is marked. The datum is marked at the higher point of the mercury level. Okay, it is inverted. So this is the higher point of the mercury level, and a horizontal line is drawn at the higher level, and that will be taken as the datum. So figure shows an inverted differential manometer connected to the points A and B. Let the pressure at A is more than the pressure at B. Let H1 is the height of the liquid in the left limb below the datum line. See, so this is the datum line, and H1 is the distance between the datum line and the center of the first pipeline, which is A. Let H2 be the height of the liquid in the right limb. So in the right limb, let H2 be the height of the liquid. See, it is marked here. Let H2 be the height of the liquid in the right limb. And now there are some descriptions. H is the difference of light liquid. See, H is also marked here. It is the difference between the mercury level in the two limbs. Then rho 1 is the density of the liquid at A. Here it is marked the specific gravity. Here it is given the density. Rho 1 is the density of the liquid at A, and rho 2 is the density of the liquid at B, and rho S is the density of the light liquid. So this is the light liquid. So you should remember that we are not using mercury in the inverted U-tube differential manometer. It is a lighter liquid that is used here. That is, the liquid used in the manometer should have a density lesser than the liquids flowing through pipe A and pipe B. Let PA be the pressure at A and PB be the pressure at B. Then here you have to take the highest point as the datum. So this is the highest point. We draw a horizontal line along the highest point, and that makes the datum. So XS is the datum here. Then the pressure above XX in the left limb. So this is the left limb. What are the pressures available in the pressure in the left limb below XX? So in the previous case, in normal manometers, we had taken the pressure above the datum line, but here the pressure is taken below the datum line XX. So here one more thing you have to note. Earlier we used to add the pressures to get the total pressure above XX. That is, earlier we used to do addition PA plus rho GH, but here since it is inverted, you have to take the difference. That is, the total pressure in the left limb below XX will be equal to PA minus rho 1 GH1. Okay, so remember this point, PA minus rho 1 GH1. Similarly, the pressure in the right limb. See the right limb, this is the datum line. What all things are available below XX in the right limb? You have H height of the light liquid, and you have H2 height of the liquid in the pipeline B. So how do you write it? PB, which is already there, PB minus rho 2 GH2 minus rho S GH. I hope this step is clear. PB is the pressure at the center of the pipeline B, and rho 2 GH2 is the pressure due to H2 height of the liquid in the pipeline, and PSGH is the pressure due to the manometric fluid for a height of H. So we can equate the two. PA minus rho 1 GH1 is equal to PB minus rho 2 GH2 minus rho SGH. From this we can write a relation for PA minus PB. PA is the pressure at A and PB is the pressure at B. So from this relation we will find out the difference PA minus PB. So this is how inverted U-tube differential manometer is used for finding out the difference in pressures between two pipelines.